Hi everybody. In this video we're going to talk about Gams modeling program. Before we start, I'd like to mention about installing the program that as you see here it's gams.com and /download screen, and first of all you should download the appropriate program for your operating system, and that requires also a list. You have to fill it out also. It gives you the demo license in which you can solve problems up to 30 variables. I think that's enough for this lecture, for scope of this lecture. Okay, now let's start defining the Gams program. I have a small presentation here. After that, I will do a hands-on application at Gams. And let's see, what is Gams? Gams is the algorithm that we are using in order to solve this kind of optimization model by converting that one. And while you're doing that, the Gams stands for General Algebraic Modeling System and is used as solving linear programs or nonlinear problems. We are focusing on this lecture only linear problems that basically used to solve constraint optimization problems with objective functions. Imagine you have a problem, a production problem in a farm, where you like to harvest three types of products: corn, wheat, and cotton, and there are land and labor constraints. And the numbers will be next slide here. I think it will help you to understand the concept. It's a basic model. Here it's a maximization problem, and objective function is 109 times x corn, 90 times x wheat, and 115 times x. Here it has to be cotton. Okay, that is the objective function, and here are our products. These are x corn, x wheat, and x cotton are variables that we can decide how much will produce corn, wheat, and cotton. So this is subject to land and labor constraints, of course. Land constraint is a simple one, that a unit of corn needs a unit of land, you can call that. It's same as wheat and cotton. So the sum of the land needs to be lower than 100. And for labor, 1 unit of corn needs 6 units of labor, so plus 4 units of labor for 1 unit of wheat, and also 8 units of labor for 1 unit of cotton. So sum of these needs to be lower or equal to 500. And here are the sign restrictions. All of them need to be non-negative. Okay, so we have this model, and in order to use Gams, we have to know some expressions and also statements. These are variables, equations, and execution commands. Generally, I can say that. Let's see what are variables, or how can we define the variables into Gams. For this, we have some special words, or let me explain variable types first. 3 types of variables are here. They are free, positive, or negative variables, and we can assign variables as they are positive or negative by using some special words. Here, it's simple actually. Positive variables means that we are going to assign or we're going to define some positive variables here. We introduce variables to the program like xcorn, xvat, and xcotton. And after this expression here, positive variables, we are gonna order these words, and between them there will be commas, and at the end there will be a semicolon. Also, variables word expresses that we are going to use a free variable after that, and also there will be a semicolon at the end. Sets are another information blocks. Some problems we are using indices, or mostly we are using indices, and we have to define some sets. This example is from another problem that let's see how it is defined. After typing sets command, we are using, for example, I, and here is an explanation. Fabrikalar means also indices for first indices of I, first meaning of I. If you put like I first, that means Istanbul, Ankara, İzmir, Konya, Adana, Trabzon, Eskişehir, according to their place. And these two slashes means that they are assigning indices to I. Another way of assigning indices is here, like K in parentheses I, means that first index of I, or Ki, or K1, stands for Ankara, and second Konya, or third one is Eskişehir. And after that you have to close with a semicolon here. A quick reminder is here that you don't have to use commas between this expression, the I fabrikalar, and K İç Anadolu, Ki İç Anadolu. You can, if you switch the line, that means that stands for literally a comma. Also, here is another example that it's sets after following A means assemblers between 1 and 3. That includes also 2. Here 1 star 3 means 1, 2, 3. Also you can line them in a basic way. Also here I means cities and 1 to 8. Alias, we are using alias when we should use two indices here, but I don't think we are gonna use them for this slide. And now let's look at some other parameters or some other statements. Here is parameters. Parameters comes with a parameter word, and to define some special values that are, for example, here it's demand, and it has an index, and we can assign some values to that indices. For example, here is demand, or talep 1 is 40,000, talep 2 is 30, and talep 3 is 25, and also talep 4 is 15,000, and we can assign them between two slashes, and by putting here a comma, we can, as you see here, there is a space here, and it means that talep 1 is 40,000. Also, you can assign some other values to capacity by writing them, one of them for each line, and closing here with a semicolon. Sometimes we need to define some scalar values that, for example, work time here. You can define it work time and between two slashes its value. Also, tabular data can be declared to Gams in table form using this table expression and give a name to the table. Here it's mesafe and it has two indices. And by doing that, for example, mesafe 11 means will give you 480. Also, as you can continue, like mesafe 21 is 130. One thing that you have to consider is you should write the values in a line here, like under one expression. Here you have to just start under this line. Okay. For equations, now we have variables and parameters, also some scalars, but we have to match them in an equation. Also, you can define equations by using equations expression here. First one is cost, the name of equation, and here it's explanation, means objective function, supply with an indices, demand with another indices, and putting a semicolon at the end. This is declaration, and we will give them the values after that. Here is cost, and this two dot means assigning the values or expressions to this equation. It is that E between two equalities means equal to. Here is L between two equality is less than or equal to, or G, as you can guess, greater than or equal to. Also, I'd like to mention sum function. Sum function is a function that works while we are using indices and summing over indices. Like here is, I think that will be easy for starting here. Demand, sum over i's, xij's greater than or equal to bj's, and that means summing all x, i's, and j's are constant here. For every j, we're gonna sum all i's, x1, x2, x3 with one j, like x11, x21, x31, etc. And it will be greater than or equal to b1 at the end. Okay, I think that is enough. Also here, a quick note. Prod means product of xij's over j. That is, as you can see here, the product function. Lastly, we have execution commands, execution commands, which are basically model, solve, and display. Model is the function that you will name your model, as here it will be example 1. And the two slashes here allows you to include the equations in your model. Also, all declaration means I'd like to include all my equations into that model, but you can specifically include some of the equations by putting them into between two slashes and writing a semicolon at the end. Solve declaration gives a command to the Gams that needs about the model that you are trying to solve, and you have to indicate which algorithm you will use, for example linear programming or nonlinear programming, And also, will it be minimizing or maximizing? Here it is solve example 1 using LP minimizing the cost value in our example. It is like the daily usage. Also, you will need to add another statement here, display statement. It will allow you to display the results of the model after running the algorithm. And here the model is called example 1 and the keyword all is a shorthand for all known declared equations. The keyword minimizing or maximizing. And these are all you need to know for just basic problems. But of course, I cannot explain, I cannot tell every detail here, but you can easily find a word or expression or command by Googling it. I hope that will be helpful. Now let's take a look at an example. As you see here, this is an explicit form of the model, and we will try to convert this model into Gams language. And let's do that. I will write this model to my notebook so that I can remember the coefficients. Now, if you open the Gams Studio, you will see an interface like this, and we should create a new file. As you can hear, I will name it as example 1. And save it to desktop. Okay. Now first, I will define the variables. Here, I think it will be better if I increase the font. So here it is, variables. And as you see, the Gams is understanding the functions and making them blue. And it's, as we here defining variables, that means the word after this will be a free variable. Let's say z. And then positive variables will be x corn, x lat, and x cotton. Okay, and we will have equations here. Quick reminder, Gams is not case sensitive, so there is no difference between writing that equations with capital E or equations. Doesn't matter, so I will delete them. And they will be objective function, length constraint, and label constraint. Now with a semicolon at the end. And we should assign some functions then by doing objective is z equals to 109 times x corn plus 90 times x lat plus 115 times x cotton. All right, now here length constraint is I will put them here, just want to see them in an ordered way. X colon plus X vat plus X cotton needs to be lower than or equal to 100. Lower than or equal to 100. And label constraint is 6 times X. Now let's write them here. 6 times X colon plus 4 times X vat plus 8 times X cotton needs to be lower than or equal to 500. And now we have variables, equations, and definitions of them, and we need to hear the statements. We should name the model by doing model. I think it's okay to give it a name like example 1. And we will use objective length equation and also labor equation. What happened? Yeah, that's right. And now we will give the order, the command to Gams that it will be solving the model. Solve example 1 using LP maximizing, because it's a maximization problem, Z, which we are after, and display X corn dot L. Oh, yeah, it should be separated from L, the comma, X vat dot L and X cotton dot L. If you don't put here the display command, then at the end in the summary page there will be no display section. That it's a shortcut for showing the results. But anyway, if you look at all the results, then you will see their values, their optimal values, if there is any. And now, yes, I think that's all. Here, as you see here, the play button, if you click on it, it will run the model and will give you the results. Okay, it worked very well, so there is no errors here. Let's close it. And see here, a new file has popped up. Double click on them, and here is your result summary. And as you see here, optimal values of variables can be seen here. If you double click on them or scroll down, you can see them. As I said, it's just a shortcut directly taking you this scene. Just make sure, let's try it. Double click on them. Yeah, it's here. It is variable x corn 50, x wat 50, and x cotton would be 0 in the optimal solution. And where is our z? Oh, here is our z is 9,950. You can see other, that's alright. Now let's see another way of doing this example. As in canonical form, you see that sum of xj's with coefficients cj's and with a summing sign. So subject to all here is the constraint aij's will be the coefficients of each constraints. In this example, j's indices will be corn, wheat, and cotton. I's are land and labor. Xj's, which are variables, will be x corn, x wheat, and x cotton, but we could define them as xj's. Okay, then coefficients in the objective function would be 109, 90, and 115. Also, this is the table form or matrix form of coefficients of constraints, and here is boundaries for constraints. Okay, let's try to do it in a different way. Now I am creating a new file. Let's name it example 1 revised. Okay, then increase the font size. Alright, now in this case we have sets like j's, which are corn, wheat, and cotton, and another set is here i's. I should land and labor will be the i's. Okay, now closing sets with a semicolon here. And now we should have coefficients which we can define as parameters. Parameter cj's will be corn needs to be 109, wheat will be 90, and cotton will be that. And we have bi's, which are land 100 and labor. For labor it will be 500. Okay, then. And we will have a table. Oh, does it work? Table. J will be is corn, wheat, land 1, 1, 1, for labor it would be 6, oh no, 4 and 8. Alright, positive variables would be xj's, free variables we can say z or profit, whatever you want. Z, let's say z. And now for equations, we should have two equations here. One is the objective and the other one can be constraint i's. And let's define them. Objective is z equals to sum of, we can write it like this, cj times xj's, cj times xj's, and here will be another closing bracket for sum function, and at the end we will put a semicolon. Another equation will be constraint. The good thing is here with a lot of variables and a lot of constraint equations, you can write them in a single line of code with indices. So that's a smart way. Constraint, I said constraint i's will be summing over j's and a ij's times xj's, and they should be lower than or equal to bi's. Okay. Now giving some statements. Name the model as revised example. And we'll be using all equations. And solve revised example here using LP maximizing Z. At the end, we would like to display the variables, x's, and you don't need to write its indices, so just put x dot l, and that's enough. Now let's run this model and see it will give the same results as the basic one did. Yeah, there is no errors here, and here is the results. As you see, let's display x's. Variables x corn will be 50 and VAT will be 50, and it does not write the cotton value, but the Z value is the same, where I can show you. Variation Z is 9,950. I think that's enough.